Hi everybody, this is Tor Storley and I am back with another video. This is the 9th video in this series about DuckDB, a deeper dive. And in this video, I'm going to move away from the CLI and I'm going to move into VSCode. And I created a notebook that is a Python, I think it's Jupyter style notebook that will basically hold my code. And the reason I'm doing that is because if you create a script and you run it over and over again, it will have to import the same stuff every time. It will have to create the same stuff every time. So to avoid that, I'm running the cells independently. So it's a lot easier, cleaner to do so. So I'm going to open up my VS Code. And as you can see here, I have the dark mode on. And I created this deep dive 24 folder just so I can import the right stuff. Notice, however, I'm using my code here. I don't see it anywhere, but let's see if we can activate the Python. Okay, control, what is it? Control Shift D, is that what it is? P maybe, Control Shift P. Okay, so Python select interpreter. I want to use this 3.12, 3 DuckDB. So down here somewhere, it's going to kind of figure that out and it's going to load that particular virtual environment. Now I don't see it anywhere, but I guess if you look up here, you can see it is actually set to Miniconda3 environments, DuckDB, Python executable. So I'm running a 3.12 version of Python. First thing you want to do is import some libraries. And as you can see here, I have pandas as PD. I got DuckDB, import that. I also import the matplotlib library. And the reason you want to do that is because Seaborn is built on the top of a matplotlib. So Seaborn is a more fancy way of displaying charts, etc., that sits on the top of the matplotlib library, according to my understanding. So again, these are naming conventions that are very common in Python, and I suggest you name them like that too, so whenever you post your code, everybody can understand it. Pandas is always PD. DuckDB doesn't really have one, but the matplotlib has a PLT, and Seaborn is typically SNS. So let me Control Enter in my Windows 11 environment for the VS. So one thing you're going to discover, and hold on one second, I'm going to bring up some stuff for you. Okay, so as you can see here from this annotation, when you work in DuckDB, there's two formats you can actually work with. Now, you can work directly in Python, meaning you can write, and if you read any Python code literature, you'll become very aware of things like, particularly for a guy like Matt Harrison or Harris. He is a 20-year-old student of pandas, and he's been doing all kinds of lectures, you name it, online presentations on pandas. And I have a few books of his, and one of his things that you will notice if you read his books is that he loves the chaining mechanism of pandas, meaning you write and command, and then you write another command with a dot and whatever the action is, dot, next action, dot, next action, and so on. And if you want to be able to do so in a few lines, meaning if you don't want to write it all on one line, you should wrap everything in a parentheses, and therefore you can, in any Jupyter notebook or whatever cell, you can write these commands and basically chain them together. And if you're interested in this, you should check out some of my previous videos. I think I had one that I did styling in Python tables and markdown tables. Why don't you check out some of those videos, and you kind of see that syntax in much more detail there, so you understand better how you can do it. Now, as far as DuckDB goes, as you can see here on the screen, there is a relational API and there's a Python DB API. And if you look at my screen here, you can see the relational API is here and the Python DB API. So what's the difference? Well, one of them is specifically applying to the database. The other one is sending instructions from Python to the database. So if you look at this, you will have a lot more database kind of syntax if you use the relational API. But if you use the Python style, meaning you can write Python commands and chain them and so forth, and then if you want to call the database, you have to basically parse out the string to make that happen. That's what the Python DB API. Now, I got this from Claude because even though I knew what it was all about, I thought, okay, let Claude explain it to you. And I said, hey, why don't you explain it to a teenager so, you know, it's not going to be too technical. But whatever it is, just remember that one of them, the relational API, you can create those in DuckDB, but you can also, in Python, you can use this DB API. And it's kind of hard to understand the differences, but it depends on what you're used to, what you're familiar with. Like Python will be more like Python code, where you actually do these dot this, aggregate this, sum this, count this, what have you. And here you have to write SQL statements inside like parsing strings in Python. And then you use a connection object to connect to DuckDB. So you basically can think of this one, the relational API, as more like a SQL-based, where you write SQL queries. Here you can think you write Python scripts, and it will still activate and run in DuckDB. So when you work with DuckDB's relational, then you can convert to different formats. So I prepared just a couple of samples here. If you look at this first one here, it returns a .df, which is equivalent to a pandas data frame. So it converts it from the relational DuckDB version into a pandas data frame. Now, if you want to fetch data, you can fetch data frame, for example, like this. This is another method you can use. You can also, if you have these installed, and if you want to install them, go to terminal and go into your virtual environment and do a pip install, like pip install polars or PyArrow, what have you. So you can install it right there into this project, okay, by using that technique. Now, if you look here, you can see I'm importing polars by using the alias PL, and then I'm running my execute, select everything from this, and make it into a polars data frame. See this .pl here? So when I run this, okay, let's run the data frame pandas first. That looks like this. And when you convert it to polars, and by the way, if you don't know what polars is, it's a much more improved speed-wise and execution-wise to pandas data frames. Polars takes advantage of parallel processing, etc. So it's much faster and more useful for larger data sets. So here I'm converting it directly from the DuckDB relational into a polars data frame. So you can run it like this, and as you can see, it gives you the conversion. Here you can see I64, so there's an integer of 64 size. So obviously some of these are overkill, these data types, but you can improve on it as you see fit. Here you can also use the PyArrow intersection of DuckDB and PyArrow to create an arrow table. So when you run that, it will look like this. And as you can see, it's a PyArrow table. And here you're given all the data columns, and then you see the data below here. So that's another very efficient non-copy version of the data you can use. And of course, you can also convert it into a NumPy array. So as you can see here, now we have a NumPy array. So those are some of the very cool methods you can use, very simple ways of converting from one format to another from DuckDB's relational. All right, enough about that. So I just wanted to mention that, and now let's continue. Okay, so here I'm back in my VSCode notebook, and as you can see, I imported pandas, DuckDB, matplotlib, and Seaborn because, of course, Seaborn is based on the Matplotlib. Now, one thing in Matplotlib you should be aware of when you work in these notebooks, you got to make sure that you use this syntax so you actually can plot it in the notebooks. You can't just say import matplotlib as PLT. You have to use this pyplot, .pyplot, for it to show up. So make sure you're aware of that. Okay, so I wrote some information here. You can see show Python type. Now, why do I do that? Well, we just talked about the relational stuff. So if you look at it, I call it relations, and I'm using DuckDB SQL. So I'm going to run this SQL query. Basically, I'm going to say query something as a text string where you say, hey, DuckDB's, and notice the two quotes here because it's inside and already a quote, so you have to have two of them. Relational API, okay? So I call that field API. And then I print it out, and then I show the results. So let's import these libraries. And okay, it's done. Now let's run this particular cell. So let's run that. And as you can see, this is the object. It's a DuckDB PyRelation object. So it's not coming from Python. It's inside DuckDB. It uses that API. And, you know, that's the one we're displaying here on the screen. It's not the Python version of it. It's the DuckDB version of the API. Now, you can also run a command called relations types. Remember, the relations refer back to this statement. So let's run that. And notice type varchar. So in other words, whatever came back from that query here was a varchar, meaning a text string. So in databases and relational databases, in case you're not familiar with it, varchar is typically the data type that you see for strings. And why varchar? Well, there's also another data type called char, but the char is a fixed width thing. So when you say char 10, you're going to get 10 positions in your text string. Whether you have 10 or not, doesn't matter. They're going to set aside 10 in your text string. So if you have only 5 characters in your text, you'll still have 10. But a varchar will adjust according to what you put into it. So it's much more dynamic. And in Oracle, this is typically called varchar2 for whatever reason. It goes back many, many years ago because they set aside the second type for their text strings or what have you. So in SQL Server and most databases, you can see varchar. In Oracle, you can see varchar2. Okay, just so you know. All right, now you can also print out the SQL query. So notice I base it on this DuckDB relations. So when I run that, you can see it produces whatever query it came up with. Now, why do you want to use this? Well, this can come in very handy to understand. For example, if you create a relation type and then you do some more sophisticated querying instead of this baby stuff that I'm doing, then you might see how DuckDB reformats your query into its own query. Because oftentimes in DuckDB, it will take your query and rewrite it so it's more efficient. But it will do it behind the scenes, so you don't really know about it. But by using this .SQL query, you can actually see what it produced. So it might come up with some weird, coding type of syntax, select blah, blah, blah from 1, 2, 4, 5, B9 or what have you. Some kind of syntax it uses behind the scenes to recreate the query, but in a more efficient way. So be aware of that. So you can use this SQL_query against a relation to figure out what actually is run in the background. So that's useful. Another thing you can do, you can run the help. Well, this tells me something. And quite frankly, I read this yesterday and this morning I looked at some videos. One thing I always wanted to do, but I don't think I ever going to be able to do, is to create some C++ code and maybe wrap it in Python or wrap it in R or whatever you, so it becomes super efficient. Because let's face it, C and C++ and Rust and all those languages, they're built for speed. And behind NumPy, behind some of the other libraries in Python, of course, it's C++ or C language behind it. That's why it's so fast. And it's vectorized, etc. But what I'm getting at here, this is very interesting to me. Now, maybe not to you, but for me it is. It says PyBind11 object. Now, according to my understanding, PyBind11 is one library you can use to wrap your C++ code so Python can talk to it. There's also something called Boost. There's something called Cython, I think, or SciPython. I'm not sure if it's Cython or Python. But those are type of wrappers that, or language converters, if you will, that you can talk to C++ code. So what this tells me is that, of course, DuckDB is written in C++. There's no secret there. So of course it's fast, and that's one of the reasons why DuckDB is so fast is because it's written in C++. But here you can see, in order for it to talk to Python, it looks like it's using this PyBind11 converter or library, whatever it is. I'm not sure. But here you can see, so that's probably a class. You can see it's called dunder methods in Python, I guess. Dunder means what? Well, it's underscore, like two of them, and underscore behind it. So those are what called dunder method or underscore method. And here you can see, so these are classes, obviously. You can see there's a contains, get attribute. Of course, you have a init, which is required for classes in Python. So anyways, this was interesting to me. I noticed that PyBind11 is being used. So that was interesting. Okay. So much for that. Let's continue. The next thing I want to do then is I want to connect to the database. In DuckDB, there's basically 3 types of databases. And I haven't really talked much about this before, but you can write it in memory. So you do :memory in here. You say :memory, and that will create a memory database. In DuckDB, they call it default.db. And that's another type of database you can use to execute something that doesn't have a destination for it. But here, as you can see, I called this database. And if you look at my directory here for Deep Dive 24, you can see I already created this database. So it exists. Now, it's very misleading. It says SQLite. It's not really SQLite. It's DuckDB. But it calls it SQLite. I don't know why. Maybe they use some code base for SQLite, so it shows up like that. I have no idea. Anyways, you can see DuckDB connect. This is the database. So it's a persistent database I'm calling. Then I want to create a table if, notice this syntax, if not exists. Now, the beauty of that is if it does exist, it's not going to touch it. But if it doesn't exist, it will create it. Where does it come from? Well, it comes from this read CSV that I have on my local drive. And if you remember here, this is the file I'm calling right there. Okay, so all I'm doing is loading the data. I tried to do this directly from Kaggle, but it didn't like it. There's a lot of security stuff in place, and you gotta have to log in and all that kind of stuff. So it makes it more difficult. So I just downloaded the file. I hope you don't mind that. So let's run this. Let me load the database. I don't have to create a table again because I already have it. Notice the syntax, describe autocells. Now, why do I have 3 quotes here? Well, you do that when you have multi-line stuff. So this is almost like in Python what you call a doc string. So you can put 3 quotes in front and whatever command you want, and then 3 quotes after. But notice what I'm doing here. I'm converting this execution into a data frame. DuckDB has this .df parenthesis to generate the result of an execution in DuckDB into a pandas data frame. You can also summarize. What does that mean? Well, summarize means you're running statistics over the columns in the table. And as you can see, you get the name of the column, type, the minimum value, the maximum value in that column, whether or not you think it's unique. Now, the next thing I want to do then is just to view a few records. So let's take a look at a few records. So I'm running con execute select star from auto sales, and then I run this fetch df, which basically converts it into a data frame. And then I'm doing a head on the data frame. So right now, this is a data frame, the first 5 rows. Of course, the index starts at 0 because that's what Python does. And so therefore, first 5 rows is up through row 4, but it starts at row 0. So as you can see, some of the data are listed here. So let's continue. Now I can also close this connection to the database, and when I do, it means I'm no longer connected. So what I'm going to do is, and remember I created a data frame up here, and I call it result. So all of these charts are going to be based on this result data frame. So here's the first one, sales distribution by deal. Okay, so as you can see, it uses a box plot. You know, the okay, I don't know how familiar you are with box plots, but these are outliers. Here is the upper, lower, here's the average, and here's most of the data. So it distributes the data in a certain way. And you can just do a Google search on box plots and you'll find out how to read these. But notice, all of the outliers here appears to be in the large category. There's nothing in the medium or small. All right, so there's one plot. You can also do sales over time. And notice I'm using the PLT and then I'm using the SNS, which is the seaborns, right? All right, so let's run that. And when you look at the second plot here, it's going to be sales over time. So when you look at this, you can see that here's the years, here's the months, and you can follow the blue label, if you will. And that will be the medium or the center of the data. And you can see how it varies above and below here, depending on what sales figures you look at. So that's another type of plot you can do. So the next plot we're going to look at is when you order by product line. So let's run that and see what that looks like. So I'm running it. And here you can see it's really not that much difference in sales by product line. You can see trucks and buses slightly above the rest, but very, very little differentiation between these different groups. Another one we might want to plot and look at is this product line. So let's see what sales by product line. Let's see what that looks like. So I'm going to run that. And as you can see, not too much of a surprise there. The classic cars, you can see they sold a lot of that. And also vintage cars is the second best seller, as you can see here. Now, however, it appears to be classic cars is like at the top of the demand list here. So that's something to keep an eye on for. And again, you can see it's based on summing up the total sales. Now, this is converted obviously into an easier reading. So you might want to fix this if you want to, get a better number here. Now, the next chart we want to look at then is how well are we doing by country? So let's find out how we sell by country. So I'm running that chart. And as you can see, by a landslide, of course, it sells most in the US, as you can see here. The second largest market appears to be Spain, and then France in the third, and so forth. And Ireland, as you can see, appears to be a pretty small portion of the sales data here. All right, let's also check and see how well we're doing as far as getting the orders out to the people who orders it. So I'm running that, and as you can see, the shipped is definitely way up there, which is exactly what we want to see. And notice disputed, in process, canceled, very low numbers. So that's exactly what we want to see. We want to get the inventory out there to the customers as soon as possible. And as you can see, it looks like we're doing pretty well there. Now, a couple of more charts, and then we'll call it a wrap. So here I'm going to do by deal size. Notice that the medium deal size is the most sought after. So that tells you the large and small sales. No, it's the medium that the customers are most attracted to. Okay, now whatever the numbers mean, you gotta have to dig deeper into it and figure it out if you want more granular information about it. I'm just showing you some plots you can do. Okay, so here is sales over time by product line. So that will be our final chart now, and it takes a little longer because it is a line chart, and as you can see, it's very busy. But notice, to no surprise, you see all this orange stuff here, and of course that's the classic cars, as you can see. And then you can see the red stuff, which is the vintage cars. So this chart is slightly different than the others, but it gives you a good overview over the different groups, the product lines, I should say, of the auto sales. So that was the end of this video. I really hope you liked the video, and if you did, give me a like and consider, if you're not already, subscribing to my channel. That would be great. Thank you so much. Have a great day. Have a great night wherever you happen to be in the world, and we'll talk soon. Bye-bye.